Hello everyone. Today we'll be starting application of derivatives. First we have L'Hospital's rule. Now L'Hospital's rule is a way to easily solve a limit question in the form 0 by 0 or infinity by infinity. You can only solve limits having this 0 by 0 or infinity by infinity form. Now what is L'Hospital's rule? Well, let's say you have x limiting to 0 a function fx by gx, which is, let's say, in the form 0 by 0 or infinity by infinity. Well, L'Hospital's rule says that this limit is equals to x approaches 0, the derivative of the numerator by the derivative of the denominator. So you can use L'Hospital's rule as many times until you no longer get the 0 by 0 or infinity by form, in which case you just get your answer. So let's solve some questions using L'Hospital's rule. Here, x limiting 0, x minus sine x cos x by x cube. So which form is this on? If you put 0 here, well, this just becomes 0 and 0, 0, 0 by 0. So we can use L'Hospital's rule. So this one, x limiting 0, derivative of x 1 minus, well, what's the derivative of sine x cos x? Well, we can use the product rule, which gives us sine x into minus sine x plus cos x into cos x, which gives us cos square x minus sine square x, which is equals to cos 2x. So we get cos 2x by 3x square. Again, if you put x here, 1 minus 1, 0, above, below 0, 0 by 0. This is equals to comma, which I'll represent as this, which is equals to 0 minus 2, becomes 2 into minus sine 2x, minus minus cancels, giving us plus 6x. Again, if you put x equals to 0 here, this again becomes 0 by 0. So x limit 0, again we use L'Hospital's rule, which becomes 2 by 6 into 2 cos 2x by 1. So here, now if we put x equals to 0 here, we will just get 1. So we'll get 4 by 6 only. This part is 1. We'll get 4 by 6, which is just 2 by 3. This is the answer. Now let's do another question. This marker is pretty dark. It will be hard to remove. What? Oops. Now x limiting 0, log natural of sine x by cot x. Now which form is this? It must be 0 by 0, right? No, it is in fact infinity by infinity form. A good way to check is easily check the numerator or either the denominator. So here, ln of sine x, this is kind of confusing, but what are cot x? Well, cot 0 is, well, 1 by 0, which is infinity, and if you have infinity on the bottom, and if you know it's a L'Hospital's rule question, it must be infinity by infinity. Now, ln of 0, well, this approaches infinity. This is a good thing to know. Because if you have something approaching 0, you can put it at e to the power minus infinity, ln of that, the infinity comes out. So here, let's use L'Hospital's rule. So what is the derivative of ln sine x? Well, it is 1 by sine x into cos x, which gives us cot x, and on the bottom it gives minus cos x square x. Now let's rewrite it in the form of sine and cos. Cos x by sine x into minus sine square x. That cancels, giving us x limit 0 minus sine x cos x. Now if you put x equals to 0 here, well, you'll just get 0. A simple question. Now let's do a final question using L'Hospital's rule. Now using L'Hospital's rule, it is simple to use L'Hospital's rule, but what you really require is, well, trigonometry as well, because in certain parts you need to convert sec into cos, cosec into sine, and you have to use some trigonometric equations, ratios, etc. Some multiple angles. So we have x approaches pi by 2 at tan 5x by 10x. L'Hospital rule. So this is 5 sec square 5x by sec square x. Now let's rewrite it as in terms of cos. So it becomes 5 cos square x by cos square 5x. Now here the derivative of this part is 5 cos square x, which is 2 cos x into sin x, which is, well, sin 2x, and on the bottom it gives us 5 into sin 2 theta, 2 into this angle, which is 10x. This and that cancels. Well, if you put pi by 2 now here, it becomes sin pi, which is, well, I forgot to mention, this part becomes 0 by 0 because we flipped the ratio. So if you put pi by 2 here, it becomes sin pi, which is 0, and here 10 into that, which is 8 pi plus 2 pi, so it's, I think, 0 by 0 form again. So let's use L'Hospital's rule one more time. So it becomes 2 cos 2x by 10 cos 10x. This gives us 1 by 5, and if we put pi by 2 now, it gives us minus 1 into, well, cos 10x, which is, well, we have 5 pi, which gives us 4 pi plus pi. I think it gives us, well, it is in the form 10 into minus 1 into minus 1, which gives us 1 by 5. So yes, like I told you, rather than derivatives, it requires some trigonometric knowledge. So cos 2x, which is cos pi, which is minus 1, cos 10 into pi by 2, cos 5 pi, so cos 4 pi plus pi. So this is just equals to cos pi again, which gives us 1 by 5. Thank you. Now hopefully you guys are able to solve some L'Hospital's questions during the examination. Thank you.